On January 20th, ThreeI Atlast suddenly showed signs of a microscopic black hole appearing near the Sun, leading many to associate it with a moment that could be seen as the Earth's final seconds. The recorded sequence of data indicates that this object has repeatedly displayed abnormal behavior such as non-gravitational acceleration, deliberate geometric structural changes, and radio signals with artificial characteristics, raising the suspicion that ThreeI Atlast is not a natural comet but may instead be an extraterrestrial technological device. The concern deepens as more unnatural indicators continue to emerge, ranging from metallic hydrogen composition and radio transmissions encoded with the number pi to the apparent ability to generate artificial spacetime distortions, with the most shocking point being a growing microscopic black hole created by the object itself, which is emitting gravitational waves containing coordinates pointing toward the Proxima Centauri star system. All of these factors increase the urgency of the event, especially as ThreeI Atlast is predicted to intersect Earth's orbital path, and they are also why many scientists warn that humanity may be facing an unprecedented extraterrestrial contact event or technological intervention, one capable of completely changing the way humans understand the universe within just a few hours. Atlast did not arrive with drama written on its surface. Atlast arrived with numbers, and numbers are often the quietest kind of warning. Tracking data confirmed a trajectory deviation of 0.12 degrees, a change that sounds harmless until the scale of space translates it into something human minds can feel. Atlast was measured at roughly 187 million kilometers from Earth, and at that distance, 0.12 degrees becomes a displacement of about 391,000 kilometers in only 6 hours. Atlast moved by nearly the distance between Earth and the Moon, and Atlast did it without any clear gravitational source that could justify the shift. Atlast was supposed to behave like a passive visitor, a cold body obeying the slow arithmetic of celestial mechanics. But Atlast behaved like a system that could revise its own path, and Atlast revised that path as if a decision had been made mid-flight. Atlast was not accelerating the way a typical comet accelerates when it warms, because outgassing usually pushes in messy directions, and Atlast was not messy. Atlast was clean enough to become suspicious, and Atlast was precise enough to make the word coincidence feel less like science and more like comfort. Atlast did not simply drift, because drift implies randomness, and Atlast implied intent. Atlast forced a single question to surface, even inside a room full of experts who prefer answers over wonder. If Atlast was not being pulled, then Atlast was being pushed. If Atlast was being pushed, then Atlast was not only a rock and ice relic from another star, because rock and ice do not choose vectors. Atlast turned a small angle into a large silence, and Atlast left that silence hanging where gravity should have been. And as Atlast continued forward, the deviation became more than a measurement, because Atlast made the measurement feel like the first page of a longer story. Atlast did not just change direction, because direction alone can still be dismissed as noise, but Atlast changed direction in a way that pointed somewhere specific, and specificity is where the mind begins to worry. When analysts mapped the acceleration vector, they found it aligned within 2.3 degrees of Earth's current orbital position, and that narrow margin mattered, because a random push in deep space should not lean so neatly toward a moving target. Atlast was not aiming at Earth like a projectile, yet Atlast was leaning toward the path Earth would occupy, and Atlast made the distinction feel even more unsettling, because a path is not a place, it is a schedule. Atlast was moving through a region where sunlight can heat surfaces and release gas, and Atlast could, in theory, behave like a comet that vents unevenly. But Atlast carried a problem that ordinary outgassing rarely solves, which is directional discipline. Atlast would need not only thrust but also control, and Atlast would need a way to maintain that control while tumbling, rotating, and travelling at interstellar velocity. Atlast, if it were natural, would have to be the rarest kind of natural object, the kind that accidentally imitates guidance. Atlast, if it were engineered, would not need to imitate anything, because Atlast could simply do what machines do best, which is repeatable adjustment under changing conditions. Atlast therefore created a fork in interpretation, and Atlast forced scientists to hold two ideas at once, because the data demanded caution while the geometry demanded attention. Atlast might be venting, yet Atlast might also be steering. Atlas might be a comet with strange chemistry, yet Atlas might also be a probe with strange priorities. Atlas might even be neither, and Atlas might represent a category the language of astronomy has not learned to name. But Atlas kept the vector tight, and Atlas kept the alignment close enough that the human brain could not stop tracing the line forward. And when the line was traced, Atlas did not point to Earth itself, but Atlas pointed to Earth's motion, and Atlas made motion feel like a message waiting to be read. Atlast was already difficult to explain in motion, but Atlas became even harder to explain in temperature, because heat is usually honest, and heat usually tells you where the energy came from. When instruments registered a surface thermal signature rising by roughly 847 Kelvin in under 90 minutes, the number landed like a quiet impact, because Atlast was far enough from the sun that equilibrium temperatures should have stayed low and steady. Atlast was not skimming the solar corona, and Atlas was not diving into an atmosphere, and Atlas was not passing through any obvious furnace that could justify such a rapid climb. Atlas therefore introduced a thermodynamic contradiction, and Atlas made that contradiction feel less like an error bar and more like a fingerprint. Atlast, in a natural scenario, could warm through sunlight, yet sunlight at that distance is gentle, and Atlast would normally respond slowly, as ice sublimates and dust releases, and the temperature curve should look like a gradual slope rather than a sudden step. Atlas did not follow the expected slope, because Atlas jumped. Atlas jumped as if a switch had been thrown, and Atlas jumped as if the heat came from within rather than from outside. Atlas forced observers to imagine an interior that was not passive, because Atlas behaved like a container that could hide a process, and Atlas made that hidden process feel active. Atlas might have pockets of volatile material, and Atlas might have regions that trap and then release energy, but Atlas would still need a mechanism to concentrate that release so quickly, and Atlas would still need a reason for the timing. Atlas did not warm like a rock left in daylight, because Atlas warmed like a system responding to a moment. Atlas, in that 90-minute window, turned heat into a question, and Atlas turned the question into a soft pressure that built behind every other anomaly. If Atlas could generate heat on command, then Atlas could also power thrust, and if Atlas could power thrust, then Atlas could shape its own trajectory, and if Atlas could shape its own trajectory, then Atlas was no longer just a visitor. Atlas became a hypothesis that radiated outward, and Atlas made the cold architecture of space feel briefly, impossibly warm. Atlas did not only challenge motion and temperature, because Atlas also carried chemistry that refused to sit quietly inside the usual catalogues of comets and drifting rubble. When spectroscopic readings suggested the presence of phosphine, the reaction among researchers was not immediate certainty but careful unease, because phosphine is not the kind of molecule that casually survives long exposure to harsh radiation and interstellar travel. Atlast, in other words, appeared to be carrying a substance that should have been broken apart long before Atlast ever crossed the boundary into our solar system. Atlast made that single detail heavy, because phosphine on its own is not a proof of anything, yet phosphine is a signal that tends to appear in conversations about life, industry, or environments that protect fragile chemistry from destruction. Atlast therefore created a dilemma that could not be solved with a single label, because a natural explanation demands unusual shielding or unusual replenishment, and an artificial explanation demands intent, containment, or manufacturing. Atlast could, in theory, trap phosphine beneath layers of ice and dust, and Atlast could release it when solar heating opens microfractures, but Atlast would still need a reservoir that remained stable through the long night between stars. Atlast could also be producing it through chemistry we do not yet understand, and Atlast could be revealing reactions that only occur under pressures and materials rarely seen on small bodies. But Atlast also invited a different hypothesis, one that felt almost too direct, because phosphine can be the byproduct of industrial processes, and Atlast was already behaving like a system with control rather than chaos. Atlast, if it carried phosphine as exhaust or leakage, would be leaving a trail that looks less like sublimation and more like operation. Atlast, if it carried phosphine as cargo, would be suggesting an interior that is engineered to preserve, separate, and regulate. Atlast did not offer a clean answer, and Atlast did not need to, because Atlast only needed to keep the question alive. If Atlast can transport chemistry that should not survive, then Atlast can also transport energy that should not exist, and if Atlast can transport energy, then Atlast can transport purpose. Atlast made the periodic table feel like a whisper, and Atlast turned that whisper into another thread pulling the mind deeper into the dark. Atlast could have been forgiven for looking like a comet, because comets are familiar in silhouette, and comets teach us to expect messy behaviour when sunlight begins to work on frozen surfaces. But Atlast did not vent like a typical comet, and Atlast did not shed material with the usual randomness that comes from uneven heating and chaotic fractures. Instead, the outflow appeared to originate from a single fixed region, and Atlast maintained that region as if it were anchored, even while Atlast rotated through space. Atlast therefore turned a simple plume into a mechanical question, because a spinning body that vents from the same spot again and again suggests structure rather than accident. Atlast, in the natural model, should show jets that wander, because as Atlast turns, different patches face the sun, different ices warm, and different vents flare and fade. Yet Atlast held the emission point steady, and Atlast behaved as if the vent had an orientation independent of sunlight, like a nozzle designed to keep its aim. Atlast made the word nozzle appear in the mind not as science fiction, but as an uncomfortable analogy, because a nozzle implies shaping, and shaping implies control. Atlast might still be natural, and Atlast might still hide a rare geometry of cracks and cavities that channels gas through one persistent throat, but Atlast would need that throat to resist collapse, and Atlast would need the flow to remain coherent under changing thermal stress. Atlast, if it were engineered, would not need luck, because Atlast could simply be built to vent with purpose, and Atlast could use that vent to generate thrust, stabilize rotation, or adjust trajectory in small, precise increments. Atlast did not shout its intentions, but Atlast whispered them through repetition, and in the quiet rhythm of a single fixed plume, Atlast offered another calm, unnerving possibility. Atlast may not be drifting at all. Atlast did not only move and vent, because Atlast also changed shape, and shape is the kind of evidence that refuses to stay abstract. On January 17th, instruments reported that Atlast transitioned from an elongated ellipsoid into a symmetric disk in roughly 847 seconds, and the speed of that transformation mattered as much as the transformation itself. Atlast did not fragment the way comets fragment, and Atlast did not crumble into irregular debris the way stressed bodies often do, because the data described reorganization rather than collapse. Atlast therefore forced a different category of explanation, because natural restructuring tends to be chaotic, while Atlast appeared to become cleaner, simpler, and more geometric. Atlast, if it were only ice and dust, should respond to heat and tidal stress by shedding material unevenly, yet Atlast behaved as if it could redistribute mass intentionally, and Atlast behaved as if it could choose a final configuration. Atlast turned a lopsided silhouette into a balanced disk, and Atlast made that disk feel like a design decision rather than an accident. Atlast also changed on a timescale that felt too deliberate, because 847 seconds is long enough to be measured carefully, yet short enough to feel like a maneuver, like a controlled sequence rather than a slow evolution. Atlast could still be explained as an extreme outgassing event that reshaped the surface, and Atlast could still be explained as a structural failure that coincidentally produced symmetry, but Atlast would then require luck stacked on top of luck. Atlast, in a more unsettling interpretation, may have been preparing for the next phase of its approach, and Atlast may have been optimizing itself for a condition it expected to encounter. Atlast did not tell observers what that condition was. Atlast only demonstrated that it could become something else, and when Atlast became a disk, the universe felt briefly quieter, because the quiet began to resemble intention. Atlast did not become a disk for no reason, because in engineering symmetry is rarely decorative, and symmetry is often the simplest path toward efficiency. A symmetric disk is a shape that can minimize resistance in certain flows, and a disk can also provide a stable platform for rotation, for thermal distribution, and for the alignment of forces that would otherwise tumble a body into chaos. Atlast, by choosing symmetry, appeared to reduce unpredictability, and Atlast, by reducing unpredictability, made the idea of optimization feel unavoidable. Atlast was still travelling through near vacuum, yet Atlast behaved as if it were preparing for a medium, because optimization is a response to environment, and Atlast acted as if the environment ahead mattered more than the environment behind. Atlast could be optimizing for interaction with solar wind, and Atlast could be shaping itself to manage heat and radiation more evenly, because a disk can spread energy differently than an elongated body. Atlast could also be optimizing for control, because a disk can present a consistent profile, and Atlas could use that consistency to stabilize thrust vectors, to dampen wobble, or to support whatever mechanism produced its earlier deviations. Atlas therefore transformed geometry into narrative, because a disk is not only a shape, it is a statement that the object can alter its own constraints. Atlas might still be natural, and Atlas might still have reformed under stresses we do not fully model, but at last would then be a rare exception, and at last would be an exception, arriving at the exact moment when timing and vectors already looked suspicious. Atlast, in the hypothesis of design, would not need to be an exception at all, because Atlas could simply be a device that adapts, and Atlas could treat shape the way spacecraft treat configuration, as something adjustable rather than fixed. Atlas did not announce what it optimized for. Atlast only made the optimization visible, and when Atlas displayed a form that looked chosen, the simplest question became the hardest to ignore. What does Atlast expect to meet next? Atlast did something even stranger than changing shape, because Atlast appeared to stop, and stopping in space is not a metaphor, it is a demand for explanation. Observers reported that the non-gravitational acceleration that had been pushing Atlast along an unexpected vector ceased, and then Atlast held a fixed position relative to the Sun near a point measured at roughly 0.97 astronomical units from Earth's orbital crossing location. Atlast was not supposed to be able to do that, because an object in motion remains in motion unless acted on by a force, and Atlast would require continuous, controlled deceleration to transition from fast travel into a stable hold. Atlast therefore turned Newton's first law into a question asked in a whisper, because the law still stands, and Atlast simply implied that a force was present even if we could not see it. Atlast, in a natural scenario, might experience changing outgassing that alters its speed, yet random venting does not usually create a clean, sustained braking profile, and Atlast would need braking that was both directional and persistent. Atlast would need thrust that points against its velocity, and Atlast would need that thrust to remain steady over hours, not seconds, because a gentle stop requires patience and precision. Atlast held position as if it had an anchor, and Atlast made that anchor feel less like gravity and more like control. Atlast could be interacting with a field we have not measured, and Atlast could be responding to forces that our instruments interpret poorly, but Atlast still behaved as if the goal was not merely to pass through the system. Atlast behaved as if the goal was to wait. Atlast did not drift away as the sun pulled on it, and Atlast did not continue along the momentum it had carried from interstellar space, because Atlast maintained its place like a deliberate pause in a sentence. Atlast, by pausing, changed the emotional texture of the data, because motion is easy to ignore when it's continuous, but a pause feels like a tension. Atlast made the sky feel aware of timing, and once Atlast appeared to stop, the simplest interpretation became unsettlingly human. Atlast was not lost. Atlast was early. Atlast did not merely stop in a convenient location, because the location carried a timing that felt too clean to be comfortable. Calculations suggested that Earth would reach the same orbital crossing point roughly 72 hours after Atlast entered its holding pattern, and that interval mattered, because 72 hours is not just time, it is a window that can be planned around. Atlast was not parked beside Earth, and Atlast was not approaching as an impact threat, yet Atlast positioned itself relative to the path Earth would occupy, and Atlast made the path feel like an appointment. Atlast therefore turned orbital mechanics into a calendar, because orbits are predictable, and anything that can use prediction can also use strategy. Atlast could, in theory, be caught in a temporary balance of forces, and Atlast could be hovering near a point where competing influences cancel out, but the data implied a maintained hold rather than a passive drift. Atlast would need to correct itself continuously, and Atlast would need to do so with small adjustments that keep the position stable as the system moves, because nothing in the inner solar system is truly still. Atlast, if it were natural, would be performing a feat of coincidence so precise that coincidence begins to lose meaning, and Atlast, if it were artificial, would be doing what any navigation system does, which is arrive early and wait. Atlast did not send a clear message that humans could read, yet Atlast communicated through timing, and Atlast made timing feel like the simplest language shared by all moving things. Atlast also created a quiet psychological effect, because a fast object passing through the solar system is a spectacle, but a fast object that waits is a question, and Atlast became a question that would not leave the mind alone. Atlast made observers imagine scenarios they did not want to imagine, because waiting implies anticipation, and anticipation implies knowledge of what comes next. Atlas might be waiting to observe Earth more closely, and Atlas might be waiting to measure something as the planet passes, or Atlas might be waiting to exchange energy, data, or alignment with a phenomenon tied to Earth's position. Atlas could even be waiting for nothing at all, and Atlas could simply be obeying physics we have not modelled, but Atlas still placed the burden of uncertainty on the human side of the equation. Atlast held the pause. Atlast held the timing, and as Earth moved closer to the crossing point, Atlast made the silence feel less like emptiness and more like expectation. Atlast did not only bend its own trajectory, because Atlast appeared to bend the space around it, and space is not supposed to behave like something that can be folded on demand. Measurements described a localized gravitational distortion roughly 340 meters in diameter, a region smaller than a city block, yet strong enough to warp light from background stars within a far wider radius. Atlast was associated with lensing signatures that matched extreme curvature, and Atlast made the night sky look subtly misaligned, as if the universe behind Atlast had been pulled toward an invisible drain. Atlast, in ordinary physics, would need an enormous concentration of mass to produce that kind of lensing, yet Atlast was catalogued as an interstellar object, not a collapsed star. Atlast therefore created an impossible contrast, because the distortion was small in size, but the influence was large in consequence, and Atlast made the equations feel like they were being asked to accept a contradiction. Atlast did not behave like a comet shedding dust, because dust cannot curve spacetime, and Atlast did not behave like an asteroid, because rock cannot suddenly generate a gravity well with a sharp boundary. Atlast made the distortion appear abruptly, and Atlast made the timing feel like activation rather than formation, because black holes do not normally appear in minutes, and gravitational anomalies do not simply switch on beside a travelling body. Atlast forced observers to imagine a device rather than an accident, because a device can be turned on, and a device can be tuned, and a device can be placed where it matters. Atlast might still be revealing a natural phenomenon we have never seen, and Atlast might still be the first example of an exotic object carrying extreme density in a stable shell, but Atlast would then be a lesson written in fearfully small handwriting. Atlast, in the engineered hypothesis, would be demonstrating control over curvature itself, and Atlast would be suggesting that gravity is not only a force, but a tool. Atlast did not need to shout to be heard. Atlast only needed to bend a few photons, because even a tiny deflection can become a warning when it repeats across instruments. And as the light behind Atlast shifted, Atlast made the question heavier than the numbers. What kind of traveller brings its own gravity? Atlast did not only present a gravitational distortion, because Atlast also presented a paradox that lives at the edge of modern theory, where the universe usually refuses to give simple answers. If the distortion near Atlast behaved like a microscopic black hole, then its existence raised an immediate problem, because black holes of very small mass are not expected to persist. Atlast, under the standard framework, would be associated with an object that evaporates through Hawking radiation, a process in which quantum effects allow energy to leak away until the black hole disappears. Atlast therefore turned time into the first test, because if such an object truly formed, it should fade almost as soon as it appeared, and Atlast should leave behind nothing but a brief ripple in the data. Yet Atlast was linked to a distortion that remained, and Atlast was linked to readings that suggested stability rather than instant decay. Atlast made the paradox sharper, because the smaller the black hole, the faster the expected evaporation, and Atlast seemed to contradict that relationship by continuing to hold the distortion in place. Atlast forced scientists to consider two uncomfortable possibilities, and Atlast forced them to hold those possibilities without choosing too quickly. Atlast might not be a black hole at all, and Atlast might be a different kind of spacetime defect, a lensing structure that imitates the signature of extreme density without actually containing it. But Atlast might also be doing something even stranger, because if the distortion truly required mass energy at that scale, then Atlast would need a mechanism to sustain it, to feed it, or to stabilize it against decay. Atlast, in that scenario, would be operating a system that counters Hawking's expectation, and Atlast would be maintaining a state that theory says should be temporary. Atlast could be supplying energy continuously, and Atlast could be using fields we do not yet measure to keep the curvature locked in place, as if gravity itself were being held open like a door. Atlast would then transform evaporation into engineering, because what nature cannot keep, technology might. Atlas did not offer a diagram. Atlast offered persistence, and persistence is a kind of message, because persistence says this is not a flicker, and persistence says this is not a mistake. Atlast remained. Atlast held the distortion, and as the minutes passed, Atlast made the simplest question feel unavoidable. If it should have vanished, then what is keeping Atlast here? Atlast did not only bend light through an unseen distortion, because Atlast was also linked to something with shape, and shape is the one thing nature rarely produces with clean intention. Observations described a cylindrical structure extending from Atlast, reaching roughly 1.2 kilometers in length, with a uniformity that felt unsettling in its consistency. Atlast did not shed a tail that diffused into a cloud, because a tail is irregular and feathered, yet this structure appeared straight, coherent, and persistent, as if Atlast had deployed it rather than lost it. Atlast therefore shifted the story from chemistry to architecture, because architecture implies assembly, and assembly implies purpose. Atlast could, in theory, be surrounded by jets that align into a temporary column, and Atlast could produce an illusion of geometry through perspective and lighting. But the reported measurements suggested stability over time, not a momentary trick of dust. Atlast held the cylinder as if it were a component, and Atlast made the cylinder feel like an instrument rather than debris. Atlast, in the cautious hypothesis, might be a natural object with an extraordinary fracture pattern, yet Atlast would still need forces to keep the structure coherent. Atlast, in the engineered hypothesis, would be doing something simpler, because Atlast could extend a device when it needed one, and Atlast could retract it when the task was complete. Atlast did not explain what the cylinder was for. Atlast only revealed that it could build a line in space. Atlast did not deploy a cylinder merely to be seen, because the most unsettling detail was not the structure itself, but what the structure appeared to do to the space around it. Measurements suggested subtle gravitational lensing associated with the cylindrical extension, as if the region near Atlast had begun to curve light without relying on ordinary mass. Atlast therefore implied a technology that treats spacetime as something adjustable, because bending light through gravity is normally the privilege of stars, and Atlast was never supposed to carry a star's authority. Atlast, in conventional terms, would need immense density to produce lensing, yet Atlast was small, and the cylinder was smaller still, which meant the effect could not be explained by weight alone. Atlast made the possibility of field manipulation feel more plausible than the possibility of hidden mass, because a field can be generated, shaped, and aimed, while mass cannot be conjured without consequence. Atlast could be using a mechanism that compresses energy into curvature, and Atlast could be using gradients that pull on photons the way a lens pulls on light, except the lens would be made of geometry rather than glass. Atlast, if this interpretation holds, would be demonstrating propulsion beyond thrust, because spacetime control can become navigation, and navigation can become arrival without acceleration in the usual sense. Atlast would then explain earlier anomalies in a new language, because Atlast would not need to push against space, and Atlast could simply reshape the space it moves through. Atlast did not provide proof, and Atlast did not need to, because Atlast only needed to keep the pattern consistent enough that doubt becomes structured. Atlast bent the background, Atlast held the cylinder. And in that quiet curvature, Atlast made the universe feel less like a stage and more like a machine. Atlast did not stop at bending light, because Atlast was also linked to a signal that did not travel through ordinary waves of radio or visible spectrum, and that detail changed the scale of the story. When detectors registered gravitational waves with a structured pattern, the implication was not simply that something massive had moved, but that something had spoken in the language of spacetime itself. Atlast, in natural astrophysics, would not be expected to produce detectable gravitational waves, because gravitational waves usually come from catastrophic events, from black holes merging, from neutron stars colliding, from violence written in the fabric of the cosmos. Yet Atlast was associated with pulses that appeared modulated, and Atlast made modulation feel like intent, because randomness has texture, but structure has rhythm. Atlast therefore turned the question from what is the object to what is the method, because to modulate gravitational waves is to control gravity at a level that civilization dreams about but cannot yet touch. Atlast. If the pattern carried binary encoding, would be using the simplest digital alphabet, a sequence of differences that can survive noise, distance, and misunderstanding, because binary does not require shared language, only shared counting. Atlast could be broadcasting through the one medium that cannot be easily blocked, because gravitational waves pass through dust, through gas, through planets, through stars, and Atlast would be choosing a channel that ignores obstacles the way a thought ignores walls. Atlast in that sense would not be whispering into space, but writing directly into space, and Atlast would be leaving marks that instruments can translate into sequences. Atlast might still be explained by an unknown natural oscillator, and Atlast might still be an exotic object whose internal dynamics create repeating strains, but the reported regularity made that comfort difficult to hold. Atlast did not behave like a storm. Atlast behaved like a transmitter. Atlast turned space-time into paper, and Atlast turned the ripples into symbols, and Atlast made the universe feel briefly less silent, not because it was loud, but because it was patterned. And once the pattern was seen, Atlast made the next question inevitable. If Atlast is sending, then who is meant to receive? Atlast did not make the idea of a gravitational signal frightening by volume, because the true weight of the concept comes from what it would require, and at last would require more than power, it would require mastery. A gravitational beacon is not like a radio tower, because a radio tower pushes electromagnetic waves into space, while a gravitational beacon would need to sculpt curvature itself, and curvature is tied to mass and energy in ways that resist casual manipulation. Atlast therefore implied an engineering scale that feels almost unreal, because to produce a detectable, modulated gravitational signature, Atlast would need to move immense energy with precision, and Atlast would need to do so without tearing itself apart. Atlast could not simply be bright because brightness is easy, and Atlast could not simply be fast because speed is common in the cosmos, but Atlast would need to be controlled, because control is what separates phenomena from tools. Atlast, if it was truly generating a beacon, would be treating gravity as a carrier wave, and Atlast would be encoding information by altering timing, amplitude, or phase, the same way human systems encode meaning into pulses and gaps. Atlast would then be choosing a channel that is both ancient and unstoppable, because gravitational disturbances travel through the universe without caring about plasma, dust, or the glare of stars, and Atlast would be sending through a medium that cannot be jammed by ordinary matter. Atlast also raised the question of why such a channel would be chosen, because a beacon is built when the sender expects distance, and a beacon is built when the sender expects to be found. Atlast could be announcing a location, and Atlast could be marking a rendezvous, and Atlast could be calling attention the way a lighthouse calls ships toward a coastline they cannot yet see. Atlast might still be natural, and Atlast might still be an exotic event misread as a signal, but the regularity of the pulses made that reassurance fragile. Atlast did not feel like a cosmic accident anymore. Atlast felt like a system designed to persist. And as the idea of a beacon settled into the mind, Atlast made the scale of the unknown feel gently overwhelming. Because if Atlast can broadcast through gravity, then Atlast belongs to a tier of capability that humanity has only imagined in equations. Atlast did not leave the gravitational pattern as an abstract mystery, because the most unsettling possibility is that the pattern points somewhere, and Atlast seemed to carry direction inside the signal itself. When analysts interpreted the modulation as binary, the decoded output was described as celestial coordinates, a precise location written in the standard language of right ascension and declination, and the coordinates were said to align with Proxima Centauri, the nearest star system to Earth at just over 4 light-years away. Atlast therefore transformed a ripple in space-time into a map, and Atlast made the map feel like an intentional choice, because coordinates are not a poetic gesture, they are a practical instruction. If Atlast was broadcasting Proxima Centauri as a destination, then Atlast could be marking a route, and if Atlast was broadcasting Proxima Centauri as an origin, then Atlast could be revealing a return address. And in either interpretation, Atlast was doing something that resembles communication more than coincidence. Atlast, in the gentlest hypothesis, might be associated with a natural resonance that happens to resemble encoded data. Yet the specificity of a star system so close to Earth makes that comfort difficult to maintain, because random patterns rarely land on meaningful targets, and meaningful targets rarely sit at the top of our own list of nearby worlds. Atlast could be sending a message outward, as if informing something near Proxima Centauri that the operation is underway, and Atlast could be sending a message inward, as if confirming to itself that the geometry of the solar system matches a plan, and Atlast could even be doing both at once, because a beacon can be a broadcast and a handshake in the same breath. Atlast, if it was designed to bridge star systems, might be using Proxima Centauri as a partner anchor, and Atlas might be treating stars the way engineers treat endpoints, as fixed masses that can hold a structure in place across distance. Atlas therefore made the mind picture a corridor rather than a journey, because a corridor does not require travel in the usual sense, and a corridor only requires that space itself be persuaded to connect two points that were never meant to touch. Atlas did not confirm which interpretation was true, but Atlas made the coordinates feel like the calmest kind of warning, because a location is a promise that something else exists, and Atlas was now pointing beyond the Sun, beyond Earth, toward a neighbour star that suddenly felt less distant than it should. Atlas did not force humanity into a single conclusion, because the data can support more than one hypothesis, and Atlas seems to thrive in the space where certainty cannot settle. If the gravitational distortion associated with Atlas continued to grow, then one interpretation is that the phenomenon functions as an energy harvesting mechanism, because a controlled gravity well near the Sun could interact with plasma flows and coronal material in a way that extracts power on a scale no conventional engine could match. Atlast, under this scenario, would not be approaching Earth for conversation, but Atlast would be using the solar system as infrastructure, and Atlast would be treating the Sun as a reservoir rather than a star to admire. Atlast could be building a system that feeds on gradients, and Atlast could be converting gravitational manipulation into usable energy, which would explain why Atlas behaves with timing and restraint, because harvesting requires stability, and stability requires control. Atlast, however, supports a second hypothesis that feels even stranger, because if the distortion behaves like a maintained corridor of curvature, then Atlast may be constructing a gateway, a structure that does not move through space but changes what space allows. Atlast, in that interpretation, would be less like a visitor and more like an architect, and Atlast would be assembling a bridge between stellar neighbourhoods by using massive bodies as anchors, which would make Proxima Centauri not just a coordinate, but a counterpart. Atlast would then explain the earlier waiting behaviour, because if a gateway requires alignment, then Atlas might need Earth to arrive at a precise point, and Atlas might be synchronizing the system the way engineers synchronize phases in a delicate machine. Atlas could be preparing for transit, and Atlas could be preparing for arrival, and Atlas could be preparing for something that does not look like travel at all, because a gateway does not carry a ship, it carries a connection. Atlas also leaves room for a quieter possibility, because Atlas might be performing a test rather than an operation, and Atlas might be measuring how a planetary system responds to controlled curvature before committing to anything larger. Atlast, regardless of which hypothesis holds, forces the same emotional truth, because the solar system stops feeling like an empty stage once something can reshape its rules, and Atlast makes the future feel like a door that is already halfway open,